So, just real quick intro. My name's Matthew Villarreal. I am from Texas, just outside of San Antonio, if you know where that's at. I am a data integration engineer at Revio. I work a lot with middleware platforms as well as building enterprise applications in Azure. And my day-to-day really deals with a lot of the ETL processes of those two topics there. I do have a background in insurance as well as business degrees in data analytics and obviously in working right now currently in that space. So I am certified in the Azure Fundamentals AZ900 and currently seeking Azure Developer AZ204 certificates. So without further ado, we will get started. So just want to outline real quick the agenda of what we can expect from here on out. So we'll first go over just a real quick overview of durable functions, what they are, and what that entails, as well as some use cases, real world examples of what durable functions can be used for, and then a live demo of it at work. And I do want to specify that, and we'll touch base on this, it'll be in Python. So just anticipate that the demo will reflect that as well. Some tips and good habits for durable functions, really important, and I think there's some cool things in there. And then really, we kind of discussed it in the beginning before I started, but I'll hold some questions for the end. I will ask probably in the middle, right before the demo, anything that we've covered so far. Anybody have any questions while I get that demo ready? But yeah, so again, thank you guys for being here, for those of you who are, and thanks for the opportunity to give that. So first things first, right? So what is an Azure Durable Functions? Durable Functions is actually an extension of Azure Functions, but with some important differences, right? And so this obviously begs the question, what's an Azure function then, right? In the simplest terms, it's an event-driven serverless platform that assists you in the development in the language of your choice. So with that in mind, again, that's just really basic one sentence of what an Azure function is. So durable function, though, is very different, not just slightly. It's under the hood of a durable function. It'll manage the state, checkpoints, can even continue runs from being terminated earlier. Durable functions also allows you to write, stateful functions in the serverless space. This is definitely one of the biggest differences than an Azure function, as just a regular Azure function is stateless. It's not keeping those states, checkpoints, it doesn't remember or continue those runs from earlier. With durable functions, you're also offered a more orchestrational framework for your workflows than regular Azure functions. Azure functions typically are a lot larger .py files that are handling complex workflows all in one. Durable functions will break that up. Because of that, durable functions allows, let's say, those complex functions that you may have, and you can separate them out and branch them into activity functions. Now, with all that being said, and I touched base on that a little bit on the agenda, today's presentation is really going to be centered around Python, but I do want to highlight that keep in mind that anything that we cover today can be done in any of these current supported languages that durable functions support. So that'll be .NET, C#, JavaScript, anything that you're comfortable with. It's really Python. So that's kind of where we'll all focus, but just want to make sure we all understand that supports all of it. So with that in mind, I want to touch base on application patterns of durable functions, right? The most natural and straightforward of all the application patterns is function chaining. And this is really what today's demo will be and what we'll kind of be focusing on. There are a total of 6 different application patterns that Microsoft highlights in their documentation. Obviously, given the time today, I will not be diving into all 6 of them, but I will be highlighting some of them, right now, especially because I think that it also showcases the flexibility that durable functions can offer, which is really important, right? I may highlight function chaining. That may not be what somebody really, desires out of a durable function. So highlighting some of the most popular and powerful application patterns is really important. So first things first, function chaining, right? So this pattern takes into account that you will be building and chaining one function to the next with the option to use the output of one to send to another. Almost like a queue system, right? It'll send one function to another. It's going to wait till that one's done and then start the next. It makes it scalable and, for lack of a better word, durable, right? So that's really the most popular, and that's really kind of some of the enterprise functions that I've built is really just function chaining, and can be a mix of others too. The next that I want to touch base on is fan out, fan in. This pattern highlights the execution of multiple functions concurrently and then sums those results. Now, it is possible to include all those processes in one function, right? But what the biggest issue with that approach would be scalability. And that's really, again, where durable functions shines. It separates all of those large processes into separate activity functions so that scalability can really improve. Now, there are some challenges, obviously, with doing that. And really, this is in large part due to the need to write code to watch the function status and waiting for that completion before you can fan out to the next. So that's really the hardest part. Now, I will note Microsoft does actually offer a good amount of code to tackle that issue. But that is one thing to keep in mind when you're using a fan out, fan in application pattern. The next one is monitor. That refers to processes that are recurring, right? So this pattern can be used in so many ways, which is why I wanted to highlight it for durable functions. And it's extremely flexible and powerful in the sense that it can be used to create recurrence intervals, manage task lifetimes, monitor processes from a single orchestration. This one I don't have a lot of time in, but it is one that I see pop up a lot on those who do utilize durable functions. So want to highlight it, especially because of the task lifetimes that it can manage and monitoring, which is really what durable functions separates itself from regular functions for. So yeah, what I want to now kind of focus on is obviously just the function chaining, right? So just going over some of those key concepts that you'll see in the demo, as well as just some basic understandings that I think we need to understand if we're going to utilize a durable function, right? So first things first is in a durable function, you're going to have what's called a HTTP starter function. This will have an expose URL to hit both locally if you run in your, let's say VS Code, which we will be doing today in the demo, as well as in the cloud in Azure. You'll see a URL exposed in Azure as well to hit to start that function. In that URL, it'll have a defined orchestrator function to go and start. When the HTTP is started, it will look for that orchestrator name defined in the URL and pass all that info into the orchestration and then start the activity functions. So that's really the important part of it is that expose URL that will name where that function needs to go. So HTTP starter may sound very basic in the sense that it's really just used to kickstart everything, but it is really important because it displays and passes on all the information to that orchestrator. That could be data, inputs, parameters that somebody's input into that URL. All of that starts there. Next thing I want to touch base on is the actual orchestrator function. This will have the actual chaining layout in the code. So you will see here what activities are in deck to go run in what order. You can pass data to activity functions and receive data back. It's almost like the home hub where all things start and end, which is obviously begs the name, right? Orchestrator. Microsoft did a great job naming that because it does exactly what it sounds like. So it will go and call those activity functions, await the return of that activity before it goes and starts the next. Now, for today's demo, we are just going to utilize kind of that terminology of it starting and waiting for it to complete. You can have multiple activity functions run concurrently. That's another powerful thing to, or at least concept to understand and to utilize. But that won't be on today's. But I do want to highlight that this is not just obviously going and doing one by one by one. You can run them concurrently. And then obviously activity functions, right? So these are the functions that are called by the orchestrator to perform certain tasks. It's in here that you'll have a lot of your ETL processes. That includes using your get, post, request, etc. You can return data back to the orchestrator or just return, hey, this was a successful run. You're good to go, orchestrator, to complete the function. So the activity functions are almost, in a sense, like regular Azure functions. It's really the function that's going to go and do all that ETL process of gathering data, doing get requests, performing the ETL, coming back with the transform data and saying, hey, I've completed. If you utilize it in that way, obviously, you don't have to limit yourself to activity functions just doing that, but that's kind of really the big power that it has. So next thing I want to touch base on is really just that basic flow in more of a visual model. I'm a very visual person, so it helps me to see, kind of what it is I'm working with so I can better understand it. This is offered on Microsoft's documentation for durable functions. It's a great one, and it's really simple. So in here, you'll obviously see each one of these little lightning bolts is really a function in itself. And then you've got the data being passed from one function to the next. So you've got your starter function here, which again, you will hit via URL that'll start and pass data, any inputs that are set into the orchestrator function. That orchestrator will then call an activity function. And right here, I kind of want to highlight, because in the function chaining portion of this, it doesn't show this in a great way, but I want to make sure that I highlight that when we call this activity, this orchestrator here is going to go to sleep. It's going to go to sleep and say, wake me up when you're done. This activity function is going to run, complete, do any get requests, post requests, ETL processes that it needs to do. When it's done, it's going to say, I've completed. Go back to the orchestrator and tell them that. It's going to go back to the orchestrator and say, hey, activity one's been completed. You're good to continue. And then this orchestrator would then go call activity two. So I do want to highlight that it's not really activity is going to then call activity two. It's really that orchestrator is going to call each. It's going to go to sleep, call one. One's going to come back and say, I've completed. It's going to go and call two. But again, I just want to highlight that. I could have probably put at the end here back to the orchestrator, but I want to highlight that we're going to go to each from that orchestrator. Next thing is really just some practical use cases for durable functions. So these are just some, I guess, real world examples of ways we can utilize durable functions in Azure. So, and obviously it's not limited to these three. These are just three I could get off the top of my head. One big one, order processing, which in my head, when I'm thinking of that, right, the function will process a payment, send confirmation when all activities are completed. In a sense, it's a really simple one, but honestly, durable functions is just that. It's a simple yet extremely effective way to code and to do those processes. This function would wait for a webhook to be generated and handle the order from there. So that's really just an order processing. You could do that as payment processing, anything that really you can think of as far as processing goes, and it'll handle that with ease. Quick, serverless, and great. Next one I want to highlight, document approval, right? So that would be an activity function would possibly send back that the recipient has signed and marked it as approved or rejected. When someone submits a DocuSign document for approval, function would handle it where it needs to go for sign off. So just imagine, right? We discussed a little bit that orchestrator is going to wait for the activity to be done. That activity can do that, right? The activity can go and send back to the orchestrator, hey, that recipient has signed it or hasn't signed it, or maybe there's a different state that document's in. That's a great way to utilize it. Really powerful in that sense. Next one I want to touch base on would be the survey or feedback collection. This is another very popular option here, and you'll see this a lot. And if you dive into the durables function space online, a lot of people use it for survey or feedback collection. I know you've seen those feedback emails, right? Where at the bottom it's got a feedback link. There may be one for this. So think about it in that sense, right? So you'll see it that email on the bottom. In this scenario, it would take the results when submitted and store them. Almost like, you go in there, fill out your feedback, or let's say this presentation, right? Good, bad, or in the middle. When you're done submitting that, you could have a redirect URL when that's completed to go start the durable function and handle the feedback that was completed in that scenario. That's a different way than what I'm currently using, but almost the same, right? And I haven't even touched base on that yet. Redirect URLs to start Azure Durable Functions is an extremely powerful way to utilize it. And that's in this scenario for the survey or feedback collection, one way to do it. So yeah. And if anybody can think of any other practical use cases just off the top of your head, you're just like, you know what, Matt, like I just thought of this would be great. Or would it work in this scenario? Post it in the chat. That's something that would be really fun to kind of touch base on at the end. So just let me know. And then while you guys are doing that, or at least chewing on that while it's being completed, I'm going to stop sharing for a second because we are going to dive into the demo, which I will kind of need my Visual Studio Code and everything. So I'm going to stop sharing just for a second while I get that up. Let me see. Sorry, just trying to get that all ready, squared away. And let me know if y'all can see my Azure function. Hopefully.
Yep, we can.
Awesome. Perfect. So we are going to start here. I first want to go over, why I'll be doing this in Visual Studio Code, because you may say, Matt, obviously Azure's in the cloud. You can go to Azure portal and utilize all that resources there. And that's true. But the reason why I want to do it actually in VS Code is I want to show some of the outputs of this orchestration and activity functions. So we can visually see that app running and really for debugging purposes too, right? So you're going to see in here, hopefully not, but if there's an error, we'll see it here, right? And it'll tell me, hey, this is what went wrong, stuff like that. So I think it's actually more powerful to see it here than in Azure right now. I will go to Azure after this to kind of show you what the function looks like over there and everything, but I kind of want to start here. So first things first, you're going to see on the left-hand side here, there's three functions right now currently, right? And I'm gonna explain it. We've got the starter function right here, a orchestrator here, and then an activity function. You can name them anything you want. These two I kept the same just as a default, and then I actually named this one activity function, call weather app. This demo here, we're really going to be giving our durable function a zip code, and then it's going to pass that on to a open weather API that I have some API keys for that I used to have for school. We're going to get some of the weather based on that zip code, just kind of live and see it output the data. So let's first start in the starter function, right? It's a natural place to start, and I think it's important. It's going to have a folder with obviously a .py file and then a function.json. Function.json is really just going to kind of give some auth level and really just some function general parameters and stuff. You'll notice here, and we'll see it in the function too, route. It's going to say orchestrators / function name. This function name is what we discussed earlier, that you need to pass it the orchestrator name so that it knows the route to go to. If I pass it something that doesn't exist or isn't correct, it's not going to know where to go. And it needs to match that orchestrator here. So this is kind of what I was discussing earlier, that the starter is very simple, but obviously extremely important as far as route and where to go. So we'll go to the durable function starter. You'll see it calls an async function here. I'm not going to get into the weeds of all this really, because it's kind of a lot to go over, and I want to kind of keep this one light and just for us to see how this is going to work. You're going to notice here we've got on the instance here we have a wait client.start new, that route parameters, and then the function name again. So you're starting to see that the pattern of it needs to know where to go from here. And then I'm also passing it input data. Now that input data is going to be a zip parameter that I'm sending in the URL. When I hit this durable function, I'm going to say, I want to know the weather for this zip code. So I need to specify in the starter if there's any parameters I want to grab, and if I want to send it to my my orchestrator. I could leave this as none, and typically it comes in, especially in a boilerplate Microsoft code that they offer, that's going to say none, just like this is. That means no data is being sent, but in this case, I want to send it data, and in most cases, honestly, you're going to be sending data. Right here, you'll notice that, and this comes in the boilerplate code as well, logging.info. This is almost just really like a print statement that's saying, hey, we've started with an orchestration instance ID, and the instance ID is just the instance of that orchestration that you've ran. So keep that in mind too. It's very important, an instance ID. We'll dive a little bit into why later on. But yeah, so that's the starter. Again, kind of a basic one, and I'm going to just kind of go sequentially here of how we also looked at that original function chaining pattern. So we're going to go to the orchestrator now, right? Same thing here. Their function.json for an orchestrator is pretty simple. And really, especially in the enterprise applications I've built, I've kept the orchestrator pretty light. I want that orchestrator just to go call activity functions and then return data. That's it. For me personally, I don't like to handle just a bunch of data in the orchestrator. I want that for activities, or I want the important stuff as far as like keys, auth codes handled in the starter before I even get to the orchestrator. So my function.json here, and typically when I'm writing it, is pretty light. I'll go into that to the .py file of that orchestrator, and this is where we're going to see, right, the calls to activities as well as the handling of the data. To handle the data that's being passed from a starter, remember we talked about I'm sending over a zip code. It's going to be handled as a context.get input, right? That means get any of the inputs that we've sent over for the starter, which is it's only one variable and one data piece. So it's just context.get input. I don't need to do get parameters, anything like that. And then you'll see here is where I actually call that activity. So result one's going to equal yield, which means wait, right? That's going to mean wait till that activity's done. This can be, I think the parameter is concurrent. I forget which one it is, but there's the one that obviously they can run. It's concurrent. Instead of yield, they'll run at the same time if you have another activity function. Right here, we're just going to do yield. So we're saying wait for that call activity. And then I got to give it the name of where to go, and then what parameter to send. So I'm sending the zip. Again, this could be none. You could do none and really just kind of handle it all over there. I don't typically do that. I'll always pass data over and return data. And then you'll see it once it's done waiting, it's saying, okay, we'll return what came back. So just keep that in mind on the orchestrator. Again, I like to keep the orchestrator pretty light, just handling the activity functions or data being passed. Now let's go check out that activity function. So here's kind of where the ETL process happens, right, in the activity function. First, let's look at that function.json because this is kind of an important one for activity functions. Theirs get a little bit not beefier, but intricate, right? So we have to have in the function.json of our activity functions the name of any variable that's coming in. Because if I don't name that zip should be coming in, and I have zip in my .py, I'm going to get an error that says, and it's a good error, thankfully. It'll tell you zip is defined in the activity function, but zip was not passed in the function.json bindings. So keep that in mind. It's got to be in there, specified what's coming in, as well as the methods that you're going to be doing in that activity function. So any post, get, really I could probably just do a get, but I add a good amount of methods just to make sure that I know that activity function is going to be able to handle anything that I want to do. So this also has to be explicitly explained in here, or again, you'll get that error saying it's not defined in the function.json. So we'll go to the weather app activity function here. Again, it's really just my API key to go gather some weather. It's an open API app. And then the URL that I'm going to go grab it. And then again, I'm kind of given all the data here of what the weather, temperature, humidity, all of that encompassed based on the zip code that I've sent. Or, and this is super important because we'll cover it later, you need to error handle in your activity function. So hopefully we don't get this part of it. We should be getting this part of it. So without further ado, I think that's kind of a good point to start our activity function. So really, you just need to activate the terminal. I like to do it from the scripts portion of it. Just make sure you back out of it when you do. And then we'll go from there. Now, you're going to see me right here, func start. There is an Azure Core Tools that you need to install in your VS Code. That is in the Microsoft documentation as well. It's kind of just everything that you need to do your testing or starting of your function, everything like that. So that's why when you see me run func start, it's recognizing everything like that because you need to download those Azure Core Tools. So I'm going to start the function first, and then we're going to see kind of what happens. Hopefully good. Awesome. Kind of as expected. So I am going to, and let me know if it's zoomed in. I'm going to zoom in a little bit just because even for anybody who doesn't have a large monitor, it may be hard to see. So we are going to see here, once it's started, we have three functions that are displayed to us, right? We've got the starter function, which we've discussed, an activity trigger, and an orchestration trigger. So you'll off the bat, when you're testing, know all the functions that you have in here and everything. Now, one thing you're going to notice, obviously, is that starter function. You're given a URL. So this localhost URL is the URL that you need to hit to start the durable function. You'll notice at the end of that URL, right, we've got the function name. Again, you've got to give it that orchestrator function name so it knows where to go. This is real easy because you could probably just copy paste that durable functions orchestrator one into, copy it from here on the output and into your URL, and you're good to go. So that's it. It's still running. So it's just kind of listening. And that's really what it's doing in Azure too when it's in the cloud. It's just listening. So I'm going to utilize Postman. And then we will send it the zip code. You'll see here zip. That's my zip. I'm not really doxing myself. It's pretty large area code. But you'll see here the URL with that durable functions orchestrator one, zip, and then the parameter. So let's send it. And really what I'm going to do first, you're going to see a bunch of stuff happening on the bottom. We'll get to that portion. But I first want to highlight here the return from us hitting that durable function. You're going to get an instance ID. Again, that's the ID of the instance that was ran of this function. But more importantly, you need to take into account these post URLs. These are really almost like your fallback. If there's issues or if you want to get the status of something, it gives you the URL to hit to get that. So you got a status query, get URL. Right there, if I copy paste that in, it'll say it was completed with a runtime, and status, everything like that. There is the the terminate post URL, and then purge history, delete URL. Now, really, both of those we're going to touch base on as well later. The terminate, you're going to use if it's continually running, and purge history, same thing. If you want to get rid of the history of this run. I have a different slide set aside for that just because of how important those two are. But I want to highlight it. Obviously, these are something that you want to keep kind of close in your back pocket, especially if you're doing debugging and running. So now I'm going to go into what happened here, right? Now you're going to see here, even at the top right there, HTTP starter function has started, right? Started with orchestration ID. You're getting all the outputs of each function that was ran. So extremely important there. You're also going to get, you'll see at the bottom, the activity function has started, and then you've got the weather for that area. So that's kind of that run there. Kind of interesting. Again, it's just a real simple call to get some weather. But I wanted to kind of showcase that what it is that that durable function can do. I will note that I want to show also the where it is in Azure, right? So I'm going to pull up Azure, and y'all can still see my screen, right? Sure.
Yes, we can.
Awesome. So I'm going to go into Azure, and if I go into my weather application, this is the same application I have on my VS Code where I'm testing. You will see same thing, right? HTTP starter, the orchestrator, and my activity function. More importantly, this is your URL. So Azure in the cloud is always going to give you for your application the URL to hit. Same thing that we talked about locally, right? So if you're ever wondering, well, what's the same URL over there? It's right here. And again, you can go into any of these functions, check out the code here. You can even test it locally, or not locally, but in Azure. And it's the same stuff that we have. So I just want to highlight that. I'm going to stop sharing for a second, and then I'm going to bring back up my PowerPoint. Perfect. Y'all should see, hopefully, demo time.
Yes, we're back on the PowerPoint.
Awesome. So, with that being said on the demo and everything, it kind of gets you guys thinking, right? When can you guys, or when should we know, right, to use durable functions? You may hear this time and time again, but it really should be utilized in environments where those complex workflows need to be separated out. That's just the core and the fundamental of the durable function. You can even take if you're thinking right now, I have a large Azure function that takes forever to run, uses a ton of resources. You can have durable functions can really help the developers really break it up, and then also follow and understand the processes of that workflow, because you're then breaking up activity functions that maybe I want to go get customer payments, and then the next activity function after that, I want to match those up with invoices. It's easier for a developer to follow that and work in that scenario rather than 200 lines of Python code in one function that runs for hours, when a durable function can do it in, let's say, less than 30 or less than 40. Another telltale sign is any long-running ETL processes are up for a durable functions candidate as well, because durable functions can spread out the time it takes to complete those tasks. So same thing there. Functions really where you want a more robust monitoring and debugging capabilities, that's a bread and butter right there for durable functions, because durable functions maintains detailed execution history, while also offering that visibility into the orchestration runs. Don't also limit yourself to durable functions. You can call an Azure function from a durable function if needed. So think more of durable functions as a tool to assist you on what your ETL processes are going to entail. So don't think here I am selling you on durable functions is the only way to go. I think it's actually almost the opposite. It should be used as a tool to help you when you're utilizing either just a regular Azure function or not, or any other a pipeline. It can be called from there. So just think of how durable functions can be implemented more than converting over to that. So we did touch base a little bit when we were looking at those management HTTP URLs from the Postman that we were hitting. So I want to touch base now on that purge and terminating. So we discussed in the beginning of this that durable functions are stateful. So this can cause a function to pick up where it left off from its previous run if, right? And these aren't the only two scenarios, but these are really the most popular and some of the ones that I've ran into early on developing into those applications is when the application was stopped before completing its calls to any activity function or before the orchestrator was finished. Okay, so let's say it errored in the start of an orchestrator, didn't call any activities, and you see that run in the output, and you're just like, okay, well, let me stop the function real quick, read the errors, make those fixes, and let's start it back up. The next time you start it back up, it's most likely going to start in that orchestration state if you haven't purged it. It's going to start right where you last had the error, and you're just going to start seeing it run, and you're going to be like, what is happening here? When it first happened to me, I was absolutely confused. I was just like, what did I do here? That was more my bad. I didn't read up a lot on the purging and terminating very early on, but it'll catch you by surprise. But it's super important to understand that portion. Really, these two topics are one of the most important things I can stress about durable functions. The other way that you'll see that it'll start off is if you encountered an error out of any of the activity orchestration runs and it wasn't handled correctly. So if this error is out in the activity function, what do you think is going to happen, right, on the orchestration? We discussed that orchestration is put to sleep, but it's still in a running state. So it's waiting for feedback from that activity. So if your activity had an error on any API calls or anything that it was doing, and it never went back to that orchestrator, it's going to continue to run that orchestration instance. So what you'll need to do is terminate. The most effective way to do this is, purge and terminate those runs when needed. Handle that. This can be handled inside of your function when errors occur or right at the beginning. If there are any run histories that were kept given a certain criteria, right? You can purge given on time, date of runs. You can give it based on instance IDs. You can base it off of status. So really there's a lot of different ways to handle it, but the most important thing is to handle it because if you don't, like I said, it's just going to cause a lot of issues moving forward, especially when you're developing. So very important topic there. Last thing I want to cover, Azure resources to connect to your durable function, right? So the great thing about utilizing Azure is they typically do a great job of making sure that their resources can connect to other resources so that you can utilize them in effective ways. So this is what I kind of want to highlight some of the good ones that you can utilize for a durable function. First thing is application insights. This particular Azure resource can be used to monitor performance, logging diagnostics of your durable function runs. This one's kind of a given because when you start and create your durable function, it asks for your storage, your Azure storage account that you want to use, which will create an app insights in there. But I want to touch on that because it may go unlooked, right? Since it's automatic, you may just think, you know what, I don't really need to look at that. I'll just look at the outputs and stuff like that. Well, no, I think application insights is a great place for you to go and test some of those queries on runs that you've had. So great resource. The next one's app configuration. This allows you to manage and update your configuration settings outside of your code. So this makes updating your parameters much easier because now you don't need to modify any of your code in any activity or orchestrator functions, right? So think about it this way, right? If you have a client code and it's utilized across different activity functions, classes that you're calling from those activity functions, and you need that changed maybe per run, that's something that needs to be in app configuration because it allows you to do it and not have to keep up with code. So very effective one. Next one's Key Vault. Used to, just as it sounds, if you haven't utilized Key Vault, highly recommend. Used to store and maintain keys or certificates that hold sensitive information to use in your function. So an example like that would be passwords, client secrets. Really, it's a staple to any function in the security of the sensitive information that you're utilizing. Next one and last one I want to touch base on, static web app. This one's a little bit more in the weeds, but you can also start a durable function from the front end, from a front end application, either by having an HTTP request sent from the front end or have a redirect call the durable function. It's a little bit more involved, but Microsoft does offer, I think it's their paid version of durable, or paid version of functions, to where you can connect them to a static web app. And I think that was a recent change. I'll have to brush up on that, but I do know that you can use a static web app. That's something that I'm looking into now on one that I'm building, but very powerful resource. So other than that, that is